Assalamu alaikum. In last video we were discussing about the oxidation states, in other words oxidation numbers of the elements in the periodic tables, and we used the oxidation numbers of the elements which have fixed numbers, fixed oxidation states, and we calculated the oxidation states of those elements which have a variable oxidation states. Today in this lecture we used same oxidation numbers, same methods. We will decide about the reactions, whether reaction is a redox reaction or not a redox reactions. First example is calcium oxide treated with carbon dioxide to form calcium carbonate. In this reaction we will decide by knowing the oxidation states that this reaction is a redox reaction or not a redox reaction. For example, in calcium oxide, calcium is the alkali metal, alkaline earth metals have a +2 oxidation state, oxygen have a normal oxidation state -2, 1 oxygen and 2 oxygen. There is a 1 oxygen. Calcium oxide have a +2 and -2 oxidation state, and carbon dioxide, oxygen, 1 oxygen have a -2 oxidation state and 2 oxygen -4, and 1 carbon have a +4 oxidation, +4 and -4 is equal to 0. And calcium carbonate, can calcium have a +2 oxidation state, and carbon have a +4 oxidation state, and oxygen have a normal single oxygen have a -2 oxidation state. In this reaction we see that on the both sides calcium have a same oxidation state, +2 on the reactant side and +2 on the product side. Oxygen have a same oxidation state, -2 on the reactant side and -2 on the product sides. And carbon have a +4 oxidation state on reactant sides, as well as +4 oxidation state on product sides. It's mean this reaction there is no change in oxidation states of any elements on reactant side and product side. It's mean it's not a redox reactions. Second one is the potassium nitrates when decompose into potassium's superoxide, maybe potassium oxides and nitrogens and oxygens. That is the decomposition reactions. In these reactions we will decide this reaction is redox reaction or not. First of all, we mention the oxidation state of the potassium alkali metals. One potassium have +1 oxidation state, 2 potassium +2 oxidation state, and oxygen have a -2 oxidation state. And nitrogen, that is elemental form always have a 0 oxidation state. And oxygen is elemental states, so it will be a allotted 0 oxidation state. See that on the reactant side potassium have a + oxidation state, and product side potassium have a +1 oxidation state. And other elements is nitrogens. On the reactant side nitrogen have a +5 oxidation state, and product side nitrogen have a 0 oxidation states. It's mean nitrogen is going from +5 to 0 oxidation state. That's the reduction process. Other is the oxygen on the reactant side is -2 oxidation state. On the product side one of the oxygen have a 0 oxidation state. It means oxygen is going from -2 to 0 oxidation state. That is the oxidation process. It means it is the redox reaction because one element is reduced and other elements are oxidized. And third one example is the reaction of acid base, that is neutralization reactions, in which sulfuric acid is treated with strong base sodium hydroxides, and salt sodium sulfate and water is produced, and oxidation state of one hydrogen is +1 oxygen, 1 oxygen have a -2, 4 oxygen -8, and sulfur will be have a +6 oxidation state. And nitrogen hydroxides have a sodium have a +1 oxidation state, oxygen have a -2 oxidation state, and hydrogen +1 oxidation state. And the product sides sodium have a +1 oxidation state, and sulfur have a +6 oxidation state, and one single oxygen have a -2 oxidation state. Water is usually is neutral. It's mean there is no change in oxidation state on reactant side and product side of any elements. It's mean it's not a redox reactions. I think you got all my points with respect to oxidation states and how we can decide this reaction is a redox reaction or not a redox reaction by mentioning, by allotting the oxidation state of each elements in the compounds of all the reactants and all the products. I think you got all my points. Thank you very much.